Hi everybody, in this video I'm going to go over how to use the periodic table to determine different properties of elements. So, when we look at our periodic table, the first thing we want to notice here is that this number on the top, that's our atomic number. That gives us the number of protons. And this number on the bottom, that's our atomic mass. That tells us an average of the mass of all the isotopes of that element. So for our purposes, we're just going to round the atomic mass to make the mass number. So in the case of beryllium, 9.012 would round to 9. In the case of something like boron over here, 10.81, that would round to 11. Okay? And a thing to note here is that the protons plus the neutrons, that equals our mass number. So to find the neutrons, we're going to do the mass minus the protons. So let's take magnesium as an example. We're going to look at magnesium as an example for all of these properties. Looking at magnesium, I see it has an atomic number of 12 and a atomic mass of 24.305. Let's write that down. Atomic number we said is 12, and atomic mass is 24.305. So from this, we can say that the mass number rounds to 24. So since protons is the atomic number, we know the protons are going to be 12. And then to find our neutrons, we're going to do our mass number, which is 24, minus our protons, which is 12, to give us 12 neutrons. Now, when we're talking about electrons, like total electrons in an atom, it's going to be the same as protons as long as your atom is neutral. And if it's not told you otherwise, you're going to assume it's neutral. So we're going to have 12 protons, 12 neutrons, 12 electrons. Cool. Now let's take a look at what else we can learn. So, in addition to the protons, neutrons, and electrons, we can find out information about our number of energy levels and the number of valence electrons. Now, valence electrons are the electrons in the outermost energy state, so the highest energy electrons that are furthest from the nucleus. And the number of valence electrons is the same number as the group number. So number of valence electrons is going to be equal to our group number. So, for example, everything in this group will have one valence electron. Here we'll have two valence electrons. And now, because we're only looking at the main group, we're going to skip this whole transition metal area and go over here to boron. This has 3 valence electrons. This has 4. This has 5. This has 6, 7, and 8. Okay? And similarly, we can figure out the number of energy levels by the period number. So everything in this over here, this is a period 1, this is period 2, this is period 3. Remember, those are the horizontal ones. So everything in that first period has 1 energy level. Everything in the second one has 2. Everything here has 3. Everything here has 4, this has 5, this has 6, and this has 7 energy levels. And if we remember, the lanthanides all go right here, so these would have 6 energy levels. And the actinides, they go here, so they would have 7 energy levels. Okay? So if we go back to our example here of magnesium, we see is in our second group, so it has 2 valence electrons, and our third period, so it has 3 energy levels. Let's write that down. 3 energy levels. and 2 valence electrons. Okay, another thing we can find out here is we can look at the metallic character. Let's get rid of all this. So when we're looking at metallic character, I really want us to pay attention to this zigzaggy line. It's right here. So anything to the left of that line, right? So anything over here. These are our metals. So metals are to the left of the line. Everything over here, to the right of the line, these would be our non-metals. That's to the right of the line. And then these few that are touching the line right here, those are the metalloids. They're the touching the line. So that's pretty much everything, except there are a couple of little exceptions that we want to be aware of. Hydrogen is a non-metal. Some periodic tables actually have hydrogen over here, so with the non-metals, but some of them have them on the left side, but we're going to remember that's a non-metal. Except another exception is over here, aluminum is a metal. But you should know that because you know that aluminum foil is a metal. So even though it's touching the zigzaggy line, it's not a metalloid, it is a metal. Okay? So let's look back at our example of magnesium here. Since it's to the left of that zigzaggy line, we know magnesium is a metal. Okay. Now we have all this information about magnesium, and we can use this to make a couple models. The first kind of model we can make is a Lewis structure. And to make a Lewis structure, what we do is we just do our atom symbol, is Mg, and then we put the number of dots around it that are the number of valence electrons, and we put them one on each side and then pair up. So magnesium we know has 2 valence electrons, so we're going to put 1 dot here, and we're done. If we had something that was bigger, right, let's say we have chlorine. You're going to put the dots like this, 1, 2, 3, 4, 5, 6, 7, okay? 1 on each side and then pair up. What I don't want to see is this. Let me explain. You don't want to go 1, 2, 3, 4, 5, 6, right? You don't want to pair them up first. Another thing we don't want to do is do 1, 2, like 1 on each side. So we want to make sure we're doing 1 on each side before we pair up in a circle sort of fashion, okay? So that's our Lewis structure. Another thing we can do is a isotope symbol or a atom symbol. We're going to call this an isotope symbol. When we're making an isotope symbol, we put the element symbol in the middle, and then at the top, we put the mass number, and at the bottom, we put the atomic number. Now these isotope symbols, that's the opposite of the periodic table, right? So the periodic table, the mass is on the bottom, the atomic number is on the top. When we make an isotope symbol, it's going to be flipped. So in the case of magnesium, the mass number is 24, and the atomic number is 12. Okay? Now there's one last thing that we could do, and that's to make a Bohr model. So a Bohr model, the first thing we want to do is we make our nucleus and we write the number of protons and neutrons, which we already figured out. 12 protons, 12 neutrons. I'm going to write P plus for proton and N0 for neutron. Now, when we're making our Bohr model, we make these little orbits. And the first orbit can hold 2 electrons, and everything after that can hold 8. So we want to add them up until we get the total number of electrons, which is 12. So our first energy level can have 1, 2 electrons. But we need to get to 12. So we're going to add another energy level. Like I said, everything beyond that first energy level can hold 8. So let's add 8 more. Okay, now we have 10 electrons, 8 plus those first 2, and we're still trying to get to 12, so we need to add a third energy level, and that's going to have 2 more electrons. So if we count that up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total electrons, and we are done. And I'm going to make a note over here that our first energy level holds 2 electrons, and that the other energy levels hold 8. And we can check here if our energy levels and valence electrons is the same as what we predicted. So we saw from the periodic table that we have 3 energy levels, and we have 1, 2, 3 energy levels, so that's good. And we said we have 2 valence electrons. Valence electrons are the electrons in the highest energy state, so this one, and we have 2, so that makes sense. Okay? Hopefully that helps clear things up. In this video, we went over how to find the atomic number, the mass number, protons, neutrons, and electrons, as well as energy levels, valence electrons, and metals. We also talked about how to make Lewis structures, isotope symbols, and Bohr models.